All right, guys, this is page 3 of the absolute value review. We're doing inequalities right now. Remember that you solve the two types of inequalities differently. So here's a less than and here's a greater than, and we're going to use different methods to solve those. Remember that you have notes on how to do this, and there are also notes that I posted in the classroom on how to do it if you don't remember. Do please try these problems on your own first and only come to the video if you need extra help or a tutorial, but please try them first on your own. All right, this is a less than inequality, and I'm going to go ahead and write that just to remind us. And remember that with less than inequalities, what we do is we write a compound inequality. And so we take the negative of this number and put it on the left, so -4 is less than the thing from the absolute value, so in this case an x, is less than, and then the number that was here. And so that's our compound inequality. Now, if there was something else inside the absolute value, like a +1 or a -2, we'd have to do some solving, but there was only an x in the absolute value, so we're done here. X is between -4 and +4, and that makes sense because you're talking about absolute value that is less than 4. So those are numbers that, when you make them positive, will be smaller than 4. That would be numbers between -4 and +4. You do need to graph all of these on a number line. And so here's my number line. And these are just less thans. They don't have an equal to, so they're open circles. And I'm shading between. One inequality, one shaded space. All right, right here for number 22, this is a greater than. And remember that we're solving these using different methods. There's a way that you solve less than and a way that you solve greater than. Greater than inequalities, you get the absolute value alone. We don't need to do that here. And then you write two inequalities. You write one where the absolute value is less than or equal to negative of whatever that number was. So it's x is less than or equal to -3. And another one that looks exactly like your inequality, but without the absolute value. So those are our two inequalities. Less than the negative of this, and then just exactly as it appears, so greater than 3. Again, if it had been an x + 5 or a 2x - 4, we'd have to do some solving, but it wasn't, it's just an x. And so I'm going to graph my solutions. These are it's a less than or equal to and a greater than or equal to, so those are solid circles, and then we shade out. And if you remember to put the less than the negative on the left and the greater than on the right, then you'll see that your inequalities and your shaded spaces line up very nicely. All right, let's look at number 23. This one is a little more complicated, but it is a greater than, which means I'm going to solve it the same way I did this one. But the first thing I need to do is make sure the absolute value is alone. So I've got the absolute value of x + 2 is -4 is greater than or equal to 7. I need to get that absolute value alone, and so I do that by moving the 4. So I'm going to add 4 to both sides. And so you get the absolute value of x + 2 is greater than or equal to 11. And only now, when the absolute value is alone, can I break that down into two inequalities. And the first one is x + 2 is less than or equal to -11, and the second one is x + 2 is greater than or equal to 11. And those are my two inequalities. It's an x + 2, not just an x, so I do have some solving to do. I'm going to subtract 2 from both sides. X is less than or equal to -13, and x is greater than or equal to 9. And again, because I put the less than on the left and the greater than on the right, this is going to line up really nicely with my number line. So here's my -13, and here's my 9. This is a less than or equal to, so it's a solid circle, and then I shade out, solid circle, and I shade out, like that. Remember, get the absolute value alone first, break it down into two inequalities, and then solve. All right, number 4 is a less than inequality. So we're back to we're back to just 1, so it's less than, and it's like number 21 that's directly above it. I don't need to do anything to get the absolute value alone. The 3x plus 1 is all inside the absolute value, so I'm going to have to deal with it after I write my compound inequality and take off the absolute value bars. So to do that, I write -5 because it's negative of that number, and then is less than the thing inside the absolute value, so 3x plus 1 is less than 5. So I have a compound inequality. I need to solve for x. If this were just an equation, I would solve for x by subtracting 1 from both sides. Well, here we're going to subtract it from the middle, and we're going to subtract it from the left and the right. And so I get -6 is less than 3x is less than 4. And if this were an equation, I would divide both sides by 3. Same thing happens with this inequality. We're going to divide by 3. And you do it in the middle where the 3x is, of course, and then you do it on both of the ends. And we get -2 is less than x is less than 4/3, which is 1 1/3, or 1.3 repeating forever. Just make sure you put the repeating over the 3. We are going to graph this. Here's -2 and here's 4/3. Again, this one lines up really nicely with your number line. There's no equal to, so it's an open circle and an open circle. And I shade between. And that's our solution. All right, number 25 is another greater than. And so what I'm going to do is I'm going to write two inequalities. I have to make sure the absolute value is alone. It is. X minus 2 is inside the absolute value, so I don't have to move anything. So I write 2, I write x minus 2 is less than or equal to -14, and x minus 2 is greater than or equal to 14. And then I solve for x. Add 2 to both sides. X is less than or equal to -12, and x is greater than or equal to 16. There are two inequalities, two shaded regions. Here's our -12 and here's our 16. This is a solid circle, and we shade that way. Solid circle, and we shade that way. All right, and guys, I'm noticing something about this review, which is that all of the greater thans had an equal to under them, and all of the less thans did not. We've got open circles on our less thans and closed circles on our greater thans. Guys, that is a coincidence. That is not a universal truth. So you could have just a greater than or a less than or equal to. Just be on the lookout for that, because that's it's just something that happened with the review. But please don't think that greater than always has closed circles and less than always has open circles, because that is simply not true. All right, guys, for number 26. We are going to solve this inequality. We've got to get the absolute value alone. The first thing I move is the 2. And so this is 3 times the absolute value of 2x plus 1 is greater than or equal to 9. And then that 3 is being multiplied, so we divide by 3. And so we get the absolute value of 2x plus 1 is greater than or equal to 3. And now our absolute value is alone, so I can write two inequalities. It's a greater than, so I write two separate. So this is 2x plus 1 is less than or equal to -3, and 2x plus 1 is greater than or equal to 3. And I can solve both of those inequalities, subtract 1 from both sides. 2x is less than or equal to -4, divide by 2. X is less than or equal to -2. Subtract 1. 2x is greater than or equal to 2, divide by 2, x is greater than or equal to 1. On a number line, here's -2 and 1. Again, closed circles just because it's a greater than or equal to. Like that. All right, guys, you can omit 27. Don't worry about it. So, just make sure you've got all the other stuff down. Don't worry about 27. Again, make sure you're working through the problems and only using the videos to check your answers. Please check out page 1 and 2 if you haven't already, and you need some help with that stuff.